We said 1 mole of a given substance, it is equivalent to its relative atomic mass, which is equivalent to 6.02 times 10 to the power 23 particles. That is our relationship we have been having ever since we started the definition of the word mole concept. So if you missed, I would request you kindly to go to the videos in the e-learning page. You download, especially that part which starts mole concept part 1, and then there's part 2. I think there's 3 up to 4. You watch those videos closely, and then you can send me maybe a WhatsApp message in case you are stuck somewhere, and I help you. Okay? But the relationship we had is this, that 1 mole of a given compound, from the definition of a mole, we looked at the way we define a mole as it is hard to count maybe the number of seeds in 1 kilo of beans. But in simple terms, if they say 1 kilo, we don't know the number of beads that are inside, isn't it? It is the same word to represent a mole. A mole is a group. We said 1 mole is equivalent to this number of particles. So if a particle has this number of, if an atom has this number of particles, 6.0 times 10 to the power 23, you see this power, it is very big. In 1 atom, like 1 copper atom, 1 magnesium atom, these are the number of particles inside. So this is where the word mole came from, 1 mole of a mole concept, that it is a substance that contains this number of particles, that is a mole. But also in relation, this mole, it is only the relative atomic mass of the substance that can contain this. We had a table that had these numbers here, up, it is here. That 1 mole of magnesium, it is 24 grams. So this number of grams contains 6.02 times 10 to the power 23 particles. Silver is 108 here. This is silver. So 108 grams of silver has this number of particles. That's the number, that's the relationship you have. As long as you have the relative atomic mass of that substance, you can get it is number of particles, the number of particles present. Okay? And also if you have the grams, you can get the number of moles that substance can have. Like if they say, find the number of moles in 6.8 grams of silver. The relationship we have here is the way you start this equation is you write this 1 mole of silver contains, this is now, they have given us grams, we say it weighs 108 grams. It is from the table. These values are always given in the table. Every question will be, they will give you these constants here. But if you can cram those first 20 elements, the predictable, the better. So 1 gram of silver has this number of grams. So the question has given you this. They want the number of moles in 6.8 grams of silver. So we say 108 grams of silver are contained in 1 mole. What about 1 gram of silver? It has 1 out of 108. These are the moles. Then the question comes in, what about 6.8 grams? 6.8 grams of this, of silver. It contains 1 out of 0.8 times 10, actually times 6.8. These are the moles. What is the answer? Yes. What is the answer if you calculate? Someone provide the answer. Yes?
0.06.
0.06 moles. Now, when you're always writing this, you give the answer to 3 decimal places to be sure. What is the third decimal place?
2.
It is 2. That is what we want. 0.062 moles. That is converting from moles. So if you don't know this relationship, mole concept is going to be hard for you. Each element has its own relative atomic mass. Okay?
Yes.
Okay. Now, to be sure, we are about to, how many people here? About 7 people. Magnesium is 24. 24. What are the moles in 2.4 grams of magnesium? What are the moles in 2.4 grams of magnesium? I'm waiting in about 2 minutes. I've seen people with charts. I'm waiting for about some few answers, about 6 of them. I've seen 2. Peace. Your hand is up.
It was a mistake.
Okay. You can lower the hand. Frida. Frida. Where has Sheena gone? She has disappeared. Okay. I've seen most of the people have the answer. Patricia, where's yours? Patricia? Patricia? Okay. I've seen. Patricia, thank you. Who else has not sent the answer? Who? Esther. Esther? Esther? Is Esther on
Yes,
display?
teacher.
Where's the
Yes,
answer?
teacher.
Where's the
Teacher, I've
answer?
just sent to you.
You
I've
have
just
sent?
sent it to you.
Okay. Thank you. So the answer is 0.1 what? 0.1 moles. Now, lead is 207. 207. I want the number of grams, the mass in 0.6 moles of lead. moles of lead, the mass. I've seen one. Let's try to speed up. Maya, that is correct. Maya, that's correct. Frida, that is correct. Cynthia, they want the mass in 0.6 moles of lead. Cynthia, Patricia, that is correct. Sheena, you're on and off. You're on and off. Let me hope you have the calculator near you. Sheena. Sheena. Sheena, unmute and talk to me. So the correct answer is Sheena. The correct answer is 124.2 grams, isn't it? We are saying 1 mole of lead weighs what? Weighs 207. Okay. What about these moles given? What about 0.6? Because this one is direct. They have not given you grams. They have given you moles. 0.6 moles is equivalent to what? 207 times 0.6. What is the answer? 124.2 what? Grams. Okay. Now, that is ordinary work. We looked at the ones of 0. The one the number of the mass in 0.1 moles of potassium carbonate. Potassium carbonate, you must first write its formula or the compound, which is this K2CO3. Then now you can get relative molecular mass. 1 mole is equivalent to relative molecular mass of that substance. Then 0.1 will give you a certain mass. This is not chlorine. This is what? So you will do this. Maybe those ones who are not there, you can do part of that. And then, so that is what we looked at last week. I just want to make a recap of what was there as we go for the next Discussion. Calculations on percentage composition by mass. Percentage composition by mass. In short, you shall write percentage composition by mass. If they say percentage composition, if all subjects are 10, and in English you have scored you have got maybe the overall percentage is 100, and a particular subject, that is our element now, let's say chemistry, you have got 90%. You have got 90%. That is in chemistry alone, you have 90, that is your element. Then out of the overall percentage is 100. Now this 100 can be our relative atomic mass or relative molecular mass of a given substance. So what they mean by percentage composition is, from the formula of the compound, we can calculate the percentage of mass of each of the elements in the compound, each of the elements. So percentage composition of an element is mass of that element out of the formula mass. Important word is the formula mass. Formula mass. If you cannot come up with the relative formula mass of a substance, then this number is going to disturb you. Make sure you know how to form compounds first before you come to this. They might say they want the percentage of copper in copper carbonate. Copper carbonate. You must be positioned to write the formula of copper carbonate before you go to this one. They will give you all the varying whatever is here. They'll tell you that copper is 64, carbon is 12, oxygen is 16. Now it is upon you to know whether copper carbonate has all these values or not. Then they want the value for copper. You say copper out of copper carbonate times 100%. That is percentage composition of copper. So if they say percent composition by mass of an element, this is what they mean. Mass of the element, you know the mass of the element here, out of the relative or the formula mass of this compound times 100. Questions are here. Calculate the percentage composition by mass of oxygen in calcium carbonate. You must be in position to form the compound here, and then the value of oxygen in that compound is what you use here. So let me take this B part. They want the percentage of water. Percentage of water in copper sulfate 5 water. Now here we are going to get the percentage of water. Water alone is this. So the percentage of that element, mass of the element, is going to be 5 water out of the whole compound, the mass of the compound, which is copper 2 sulfate 5 water times 100. Now hydrogen from the table, hydrogen has 1. It's going to be 5 into 2 times 1 plus oxygen, which is 16, out of copper is 64 plus sulfur, which is 32.
32.
Yes, plus oxygen, which is 16 times 4. These ones are in different brackets. Then plus 5 water, which is this. 5 2 times 1 plus 16 times 100%. So our water is going to be, this is 2 times 1, which is this, plus 16, which is 18. 5 times 18, what do you get? It is now 90 over, this is 64. 16 times 4 is 64 plus 32 plus 64, which is 160, plus 90, of the water, you get 250 times 100%. So 90 divided by 250 times 100 is the same as 36%. So the percentage composition of water in this element is 36%. Is it clear? Yes? So anything they tell you, as long as you know how to write nitrogen in nitrogen dioxide, you must know that nitrogen dioxide is NO2. Percentage composition of that, oxygen, all things are there. Now, there is this tricky question, Roman 3. Roman 3. Roman 3 reads, a metal sulfate X2SO4. This is 3. Contains 28%. This is for the metal. X alone is 20 what? 8%. Isn't it? Yes?
Yes.
Let me hope I'm not talking alone. Are we there? Yes? Okay, very good. Now people are awake. So they are saying, this is Roman 3. A metal sulfate X2SO4 contains 28% by mass of metal X. Now this 28% is for what? Is for? 28% is for what? Is for the metal, isn't it? Metal X. What is the percentage of the sulfate? Percentage of the sulfate is what?
Not given.
Yes, but you can determine.
Yeah.
Yes? It is what? It is 72%. Total percentage is 100. If the metal has taken 28, the remaining percentage is for the sulfate, which is 72 what? %. Have you known how to get it?
Yes.
Okay. So here, this is 72. A sulfate alone is 72%. Now you come back to this formula here. They want you to determine the relative atomic mass of X. How can you get the relative atomic mass of X? This substance here, X. And then the relative molecular mass of the whole substance here. You see the difference is relative atomic. Atomic is for one element. They want the atomic mass of X. Then also, they want the overall relative molecular mass for all of them, X sulfate. You can't get it because you don't know X. Neither can you use this, but if you know this, you can get that value of X. Is it clear? So here, what you do is a metal X. Okay, we know that from percentage composition of X is the same as the mass of X. Mass of what? X, because we don't know it is X, out of mass of the whole compound, which is X2SO4. This is 3 times 100%. So now the percentage of X is 2. We don't know X. There are how many 2X's, isn't it? Out of 2X plus, now this is 3 in 2. What is the mass of sulfur? It is 32, isn't it? Plus 16 times 4 times 100%. So here we shall have our equation that has X in it, which is 2X out of, this is 2X plus what? Somebody get for me that one. This is 64 plus 32 times 3, which is 288 times 100%. Now, They gave us a percentage composition of the metal, isn't it? Percentage, this percentage was what?
72.
Is it 72 or 28?
28.
So this one is 28%, isn't it? Now, this one here, we shall have two equations that have x and what in it. But if we use the one of sulfur, the one of sulfate, we shall get, because we know the mass of a sulfate, isn't it? Yes? Can you calculate the mass of a sulfate in this compound? What is the mass of the sulfate? Here. SO4 times 3. What is the mass of this substance? Do we have calculators there? Yes? Hey, Cynthia, where's the calculator? Please.
Yeah, what's the mass of
Mass of
sulfur?
what? Sulfur is 32. S is 32. O is 16.
I've got 156.
100 and what?
56.
So we said O is 16 times 3 plus sulfur, which is 32 times 3. What have you got? My answer is here. A sulfate alone. What is the mass of a sulfate in this compound? Yes? Cynthia, unmute and give me the answer. The mass is what? Yes? Esther, peace, what is the mass of a sulfate in the compound? I'm going to leave this one at this stage. But we can also proceed with this. We say divide this by 100, isn't it? Yes? Divide by 100%, divide by 100 what? Percent to remove it from here. So this one will go 28 divided by 100. What do you get? Okay, Maya have seen. 28 divided by 100. 0.28, which is the same as 2x into 2x plus 288. Now, what do you do to remove this one? To put the x's, you bring the x up and then take this one down. Okay, let's cross multiply. Take this one there, this one that side. You shall have 0.28 into 2x plus 288, which is the same as what? 2x, isn't it? This is mathematics in chemistry. Okay? We want the x's together. We open the brackets. 0.28 times 2, what do you get? 0.56x plus 0.28 times this one, what do you get?
80.64.
Yes?
80.64.
80.64, which is the same as 2x. Now, we will take this one the other side. What do you do if you want to take this one the other side?
Subtract.
We subtract. So 2 minus 0.56, what do you get?
1.44.
1.44. X is the same as 80.64. Divide by 1.44, divide by 1.44, what do you get? X is
56.
56. Is it the answer we have here as X?
Yes.
Okay. So now, what is the relative atomic mass, relative molecular mass of X2 SO43? What is the relative atomic mass? Relative molecular mass, sorry. You have got X, substitute X and the rest, you get from it relative molecular mass. This is what we have here. X2, X is 56, substitute in the formula and get the formula mass of that substance. The answer is yes. Okay. Maya, thank you. Cynthia, what is the answer? This, that is correct. So when you look at this answer here, there is some value that's not there. You get it? So the correct answer is 400. Is it clear? Yes? We have less than a minute to finish. We can join back after 1 minute and then we proceed.